Hello guys. So we are going to continue the discussion with respect to RAG. Already till now we have understood what is RAG, then what are the main drawbacks we are fixing with RAG. And along with that we have also understood how the RAG pipeline is, right? It usually consists of two important pipeline. One is the data ingestion pipeline and one is the retrieval pipeline, which includes this two box. Okay. Now we are going to go ahead with some kind of practical implementation. Now, the major thing that usually comes in my mind, right, whenever we go ahead and start any new series, that is how should we cover a specific topic, so that we can understand the coding from basics and we move towards modular coding. So that is how I'm going to implement this entire pipeline. Initially, we will go ahead with some basic code. We'll try to understand the fundamentals. And then we will start writing more complex code. We'll be using modular coding also. So initially we will write all the code in Jupyter Notebook, then we'll increase the complexity, we'll write code in terms of class, reusability, and then we'll try to see that how we can actually create the pipeline. So that is how the agenda will probably go ahead as we go ahead, right? So two important things that we'll think about. The first important thing is to understand about the document structure. Now, whenever we work with any external knowledge database, any data that needs to be fed into the vector DB, you definitely need to know about this document structure. Why? Because inside this data ingestion pipeline, the first step is data ingestion. Now, whenever we talk about data ingestion, here we can have any kind of files, right? We can have PDF files, HTML file, DB file, Excel file. Our main aim is to read all this particular file content and probably convert into a structure wherein we can additionally we can apply strategies like chunking, embedding, and store it into the vector DB. That is what this entire pipeline is all about. So for that, you'd really need to understand this document structure. So if you see this diagram, right? So since these two are the main topics that we are going to cover in this particular video, initially we will go ahead with document structure, understanding this, and then we'll try to build our complete RAG pipeline. In our complete RAG pipeline, we have two important steps. One is the data ingestion pipeline, and the other one is the query retrieval pipeline. Now, whenever we talk about the data ingestion pipeline, let's talk about this in complete depth, right? So initially you have this data ingestion pipeline. In the data ingestion pipeline, the first step is data ingestion. That basically means, let's say that you may have different kind of files like PDF, HTML, right? Excel, you may have DB file, you may have unstructured file, any kind of file format. So in data ingestion, what is our main strategy is that how to proceed with reading this particular file, how to perform data parsing, and then finally how to convert this into a document structure. So that is the reason in this video, right, as I said, we're going to first of all understand about document structure, how to build this document structure, what is metadata. Now inside this document structure, you will be learning about important components like metadata. You'll be learning about content. You'll be learning about how the structure of the metadata exists, each and everything, right? So we will be covering completely in depth, like how these things actually work, okay? Once you understand this, this data parsing is really, really important step. Because of this, later in the retrieval pipeline, that is the query retrieval pipeline, based on this parsing, it can become much more efficient, right? You will be able to get the results much more accurate. So that is the reason you need to really focus on the data parsing. Now, after doing the data parsing, the next step usually is something called as chunking, right? So here in the chunking, we convert this entire data into chunks, multiple chunks. So this chunks is like, let's say this is my chunk 1, this is my chunk 2, this is my chunk 3, this is my chunk 4. Okay. Then as we go ahead, after applying chunking, so chunking basically means, and why do we apply chunking? Chunking strategy is very simple. Whatever documents we have, we are just dividing this into smaller parts or smaller chunks. The reason we do this, because whenever we consider with respect to any LLM model or any embedding models, let's say here the next step is all about embeddings. Okay. In embedding, with respect to every LLM model, there is a fixed context size. Okay. Let's say if I take the complete 100 pages PDF and I directly try to give it to an LLM model for performing the embeddings, like if I give it directly to an embedding model for performing the embeddings, and embedding basically means you convert text to vectors. It will not be possible. It will say that, hey, you are providing data more than the context size, and that will not be possible in order to convert the text into vectors. So within the limit of the context size, you really need to give the data. And this is for both embedding models and even in the later stages whenever we use any kind of LLM model, because for every LLM model there is a fixed context size. Yeah, different LLM model may have different context size. So that is the reason, and it is always a good strategy that we try to divide our data into chunks so that we fit them in a way that we in the later stages will be able to efficiently put them into the vector database, which is this. So after chunking, for every chunk we go ahead and apply embeddings. Okay, so we go ahead and apply embeddings, and from the embeddings we finally store that into our vector DB. Now inside this vector DB, all this will be stored in the form of vectors. Like let's say this is my record 1, record 2, record 3, record 4, like that, right? So this is one record, 2 record, this is my third record, then fourth record, fifth record, right? Like this you have, right? Now from this particular vector DB, you will definitely be able to apply any kind of similarity search. Similarity search. Now, in this specific video, what we are going to do is that I will be using any of this file and I'll create this entire pipeline. Okay, I'll just create this entire pipeline, and you also need to probably work along with me. Later on, for any other files, I will give you an assignment. Okay, I will show you with a couple of files. Let's say I'll take PDF file and I'll show you this entire data ingestion. Then what you do is that as an assignment, you use any of the other file format, let's say Excel, CSV, whatever file format you want, and you try to complete the same pipeline. Okay, so that is what is my strategy. And please make sure to complete the assignment also. And we will go step by step completely from scratch so that everybody will be able to follow. So first of all, I will go ahead and open my empty folder. And in this, remember, I will be using LangChain. And this is just a traditional RAG right now. In the later stages, we will move towards agentic RAG. So from this particular command, I will just go ahead and open my command prompt. I will open my VS Code. So let me quickly go ahead and open the VS Code. Now from the VS Code, the next step will be that I will quickly open my terminal. And let me just go ahead and write UV. I'll just go ahead and initialize this particular workspace as my repository. So YT RAG is my workspace. Now I will just go ahead and create my environment. So if you're using UV package, so you can just write UV venv. So my Python 3.13.2 will be the recent Python version that I'm specifically using for this particular project. And then I will go ahead and activate this particular environment. Okay, perfect. Till here, we are good enough. Now I will go ahead and create my requirement.txt. Now from this requirement.txt, let me quickly go ahead and install some of the packages like LangChain, LangChain core, LangChain dash community. These all things are there. Let me quickly go ahead and install these packages. So uv add -r requirement.txt. Okay, txt. So this is done, and along with this, I will also go ahead and install some of the libraries like PyPDF, PyMu PDF. Okay, so these are all libraries I'll be using. I'll talk about why I'm using PyPDF, PyMu PDF, right? This is specifically to read my PDF documents. So one example that I'm actually going to show you is with respect to PDF, and then you should also try to create the same pipeline with the help of any other data types. Okay, data formats types. Like let's say it can be JSON, it can be anything as such. So my requirement.txt is filled. Now what I will do is that I'll quickly go ahead and create my data folder. And here I will also go ahead and create my notebook folder quickly so that I can start working on it. And then along with this, I will also go ahead and add uv add ipy kernel. Okay. So that I will be able to work along with my Jupyter notebook. So ipy kernel has got executed. Now quickly, I will first of all start with my Jupyter notebook. And at the first thing that I told you, it's related to document data structure, right? Document. What is document? And what is how document can be very, very helpful if we are using in the document data in the data ingestion pipeline. Okay. So I will quickly select my kernel. And these all things you really need to be a good at Python programming language. See, there cannot be anything that you can skip Python programming language. So my suggestion would be never do that. Okay. So Python is must. And this time I'm just going to use some more advanced coding. And it will not be possible for me to write line by line. So definitely I'll go a little bit fast in order to explain you. Okay. Now, as I told you, if I go back over here in the data ingestion, our main aim is to load some data, apply some chunking, then convert into embeddings, and finally store it into the vector DB. That is what my entire data ingestion pipeline is all about, right? For understanding this, we need to understand the document structure, because all this chunking that is done, the final output will be documents. Now, what exactly is a document data structure? So here I will go ahead and write what exactly is a document data structure. So for this, I will go ahead and import from LangChain, or to probably show you this, I will be showing you some kind of file so that you'll be able to understand it. Okay, let me put this file over here. Okay, I have some file over here, and then we'll try to understand. Okay, what exactly is a document structure? See, LangChain document structure. So LangChain document is a kind of a data structure which will be able to save some data in some format where we have two important things. One is the page content and one is the metadata. The page content will basically have the content that is present inside that particular file. Okay, so if you are reading the file, inside my page content, all those detail, all those content that is present inside the file will be available over here. And metadata will be some more additional information of the file. Like it can be the file name, it can be how many number of pages are there, what is the timestamp of the file, each and everything. So this way, whenever you read any kind of data and you convert them, right, in a document data structure, this format will be very, very important, because at the end of the day, we will be doing the embedding on this particular data and pushing it into the vector DB. And when we do that specific task, pushing into the vector DB, we will be able to apply different algorithms like similarity search, cosine similarity, and we will be able to retrieve the results. So here you can see that all the information regarding this is given over here. So usually LangChain document structure, it has two important core components. One is page underscore content and one is metadata. And here page content will be the actual text content, where all it will be very, very handy in research papers. If you want to probably create a RAG application on research papers, product manual, so you can specifically use this. In LangChain, you definitely have different loaders. Okay, loaders, like you have something like PDF loader, you have CSV loader, you have web-based loader, you have directory loader. Now see, all these loaders, what it does is that for PDF loader will be used to load the PDF files. And once it loads the PDF file, right, it will be giving you the output of the documents in the form of a document structure. Okay, I will show you practically also why I am specifically saying and stressing on this. Okay, it will definitely give you all the output in the form of a document structure. Similarly, in the case of CSV loader, here we are giving the CSV file, but it will try to convert the entire content that is present inside that CSV into a document data structure. Similarly, with respect to web-based loader, directly loader. Similarly, there are so many different loaders over here. Right? You can use any of this particular loader to load the data, and at the end of the day, this loader will finally give you the output in the form of document structure. Okay. So I hope you got an idea about what exactly is document structure itself. Okay. So now quickly what I will do, I will go ahead and start explaining you about like how we can start with the document structure. So for the document, we need to import from LangChain dot, there's something called as text splitter, and LangChain underscore core. It is present inside underscore core dot documents import document. Okay. Now this document, you will be able to see that if you just hover over here, you will be able to see class for storing a piece of text and associated metadata. Okay. Now, if you really want to understand the document structure, so first of all, I will go ahead and create one document. Let's say manually I'll go ahead and create. So I will use this document, and inside this, we will be using two parameters. One is the page content. Let's say this page content I'm writing, this is the main text content, I'm using to create RAG. Okay. So I've just basically written some basic content over here. Let's consider that this particular content is coming from a txt file. Okay. But along with this content, if you really want to improve the search query retrieval from the vector DB, you need to also go ahead and write metadata. So the second parameter that you will be able to see is something called as metadata. Now inside this metadata, you can write different information, because at the end of the day, this is text. You can write like, okay, fine, this is my source. The source is basically coming from example.txt file. Okay. Then let's say the number of pages are equal to 1. Okay. Total number of pages are like 1. I can also go ahead and write some more information like, okay, who is the author for this? Author is nothing but Krish Nayak. So this is the additional details that you will be able to see it. Okay, fine. Let's go ahead and write date created. So date created. Right, date created, and here I can go ahead and write 24 minus 01 minus 01, like that's like first 2024 or first 2025. Now why these all metadata will be really important? Because once we consider this document, right, once we do the chunking, once we do the embedding, and once we store into the vector DB, when you're doing the similarity search, you can also apply filters. That is the most important thing of this. And when you apply filters, let's say that I am applying a filter, I'm searching what is the main text content for building the RAG. Some information is there. Let's say there's some information related to the RAG. If I ask that particular question and I say by author Krish Nayak, I just had that particular filter, then it knows from which document to probably pick up, because it is going to apply a filter by using the name of author, right? And that is why this metadata will definitely play a very important role. Now, if I just go ahead and execute this doc, you'll be able to see that, fine, I'm getting this particular document. Here you can see metadata is there, and as you go ahead, you'll also be able to see page underscore content. Right? So these are the two main important parameters with respect to this, which everybody can probably go ahead and use it. Okay. Now, I hope you got a very clear idea about it. Now what I'll do, I will just go ahead and create a simple txt file. Okay. Now for creating a simple txt file, what I will do, I will just go ahead and import OS. Okay. And I'm saying os.make directory data/text file. So I'm trying to create this particular, inside this folder, I'm creating this particular folder name. Okay. And if it already exists, I'll say that don't do anything, right? So as soon as I go ahead and execute it, you'll be able to see that, okay, it is going inside the notebook file. I'll remove this and let me go ahead and write /. Let's see. Now you can see over here, text file is present. Okay. So text file, I've just done that inside this. Now let me go ahead and manually create a text file with the help of Python code. Okay. So I will just go ahead and use a Python code. See guys, these all are basic Python code. I don't want to write each and every line of code and make it very big. Our main aim should be that understand concepts, quickly show you multiple use cases, and then try to implement this. Okay. So now you will be able to see I have created this simple text. I've given the file name something like this. So let me go ahead and write this to data text files python intro.txt. And this is some content that is present inside that particular key name. Okay. So this is my file name. You can see this is key is my file name. And then here I have specifically my Python content. Okay. Here I'm saying for file content in sampled underscore text.items, I'm telling to open the file name. I'm saying that, write the content. Okay. So this file path is nothing but my file name. Okay. So if file is not there, it will try to create python underscore intro.txt. So now if I go ahead and execute this, so it is saying me no directory. Okay, let me just go ahead and create one file. Okay, python intro text file. Okay, I have to give the path because there are two files that is over here. One is, okay, one file is also over here. Okay, so I'll just go ahead and write dot dot. Okay, so now here you can see my sample files has got created, machine underscore learning.txt and python intro.txt. Now what I will do, see, I've created some sample file. I could have also manually created it instead of doing the code. Okay. But I really wanted to show you all these things. Now what I will do, I will show you how to read this particular text using text loader. So one of the loader that is present inside LangChain is something called as text loader. So here I will go ahead and write from LangChain dot document loaders import text loader. Okay. Text loader. So here we have imported text loader, and along with this, see, if you don't want to also use this, see, if I execute this, this is also there. Before, if I talk about it, right, when LangChain keeps on changing its library here and there. So there we used to use LangChain underscore community dot document loaders. This also we used to use import text loader. So any of them you can actually use unless and until you get a deprecated warning. Okay. Now, the question is that how do we go ahead and read the text? So I'll write loader is equal to, I will initialize text loader. Let's give the path. The path is nothing but parent folder. We go to the parent folder data slash text underscore files slash python underscore intro.txt. So here I have actually given my file name, whatever file name we have actually created. And we can also go ahead and use encoding UTF-8. Okay, encoding UTF-8. So once I do this, okay, and now once I go ahead and read this loader, now what it is giving? It is giving me an object of text loader, right? Now in order to get the content inside this, I will be using loader.load. Okay, and here you will be able to see that I will be getting the document. Okay. Now let's go ahead and print the document. So I will write print document. So let's say this is my document. I'm going to print it. So here you can see in the document, you are getting metadata. You're getting the entire information, and this is your page content. Now this is what it is doing, right? This text loader is by default giving you the data in the document structure as soon as it is reading. And here the best part is that you can also see some of the metadata information has also got updated, like what is the source, right? You can still go ahead and manually change more information inside the metadata. But by default, the best part is that whenever you're using this all libraries, then also it will be able to give you the content in the document structure, which is really, really good. Because in the document structure, you have two important things. One is the metadata and one is the page content. So this is with respect to text loader, right? I've just read the text loader and I'm able to get this in this way. Okay. Now, one more way what I will do, I will show you with the help of directory loader. Like if I have all the important files in my directory, can I read it like that also or not? Okay. So for doing this, let's use one more library, which is called as directory loader. Right. So here you can see LangChain underscore community dot document loader import directory loader. Now inside my directory loader, you can see that I'm giving this particular file. Again, this file should be parent folder does this. And here I've given the pattern to match. See this function, basically you can give a pattern to match all the files. Then you can use loader.class. Loader.class basically means which file you are planning to load. If it is a PDF one, you can directly go ahead and use PDF. Okay, so what I can actually do is that I can also go ahead and insert PDF files over here. I can also provide this in the form of list so that it will be able to read both the content. Okay, so once I go ahead and execute this, you can see here also I'm using the encoding and all these things. And here you can see once I go ahead and write directory underscore loader dot load. Okay, and here you will be able to see documents. Okay, and then now if you just go ahead and print the documents, you should be able to see this. Okay, I'm getting an error. To log the progress, please install pip install tdqm. Okay, so here we have enabled the parameter show progress is equal to true. Let me make it as false so that I don't need to probably go ahead and install this. Now here clearly you can see that there were two text txt file. I got two documents. Yes. Now further you can do chunking and all, right? Based on the number of documents over there, I was able to get it, right? So this is the most amazing part about this. Now what I will quickly do is that let me go ahead and create a PDF file also. Okay, so here I have some examples of the PDF file. Okay, so let me quickly go ahead and copy this and paste it over here. Reveal Explorer, data. I have text files, I have PDF files. Now inside this PDF file, now my main aim is to read both the text and PDF files. Let's see. So here I have attention PDF, this PDF, this PDF. Okay, so this is my one document. Okay, let me go ahead and write the same code, copy and paste it over here. And this will basically be for the PDFs. So for PDF, I will be having from LangChain underscore core dot document loaders import PyPDF. I think PyPDF is not available over here, but let's see where is this specific library. I'm just checking out the documentation. PyPDF. Oh yeah, it should be there. So it should be here inside my community.document loaders. I have two different types of library, PyPDF and PyMuPDF. PyMuPDF is better when compared to PyPDF. It can see PyPDF shows load and parse a PDF file using PyPDF library. And similarly, if you go ahead and see PyMuPDF, it loads and parse PDF file using this, provides method to load this is there. All the information. You can see the differences, which one is better, which one is not better in the later stages. Okay. Now what I'm doing is that I will give the path over here. So from data /data, and here you can see the path is nothing but PDF. Here I will go ahead and write PDF instead of writing text loader. I will go ahead and write PyMuPDF. Let's go ahead and use PyMuPDF. I can also include encoding in this. And here what I will do, I will quickly write PDF underscore documents is equal to directory loader dot load. Okay. And then if I just go ahead and see PDF documents, you should be able to see there are so many different PDFs. Okay, I'm getting an error. Get text got an unexpected argument. Okay, let's remove this. I will not be requiring. I think we don't need to apply any encoding by default. Okay, so here you can see I have got all my documents. Yes. So how many different files were there inside PDF folder? One is attention.pdf, embedding.pdf, object detection. These are some of the research paper. And with respect to this all, we are able to see this. And now the best part is that when you're using PyMuPDF, here the metadata information is completely different. See, creation date, source, file path, total pages, right? Format, see, total pages is 15 for the first one, then 27, then 21. See, you can see it so beautifully. It is there. See, I have also created some of the PDFs there. Also, you'll be able to see some kind of author's name also, right? It tries to bring up all the entire source information, and this is your page content, right? So beautifully you are able to see the entire content quickly, right? So that is what this all PDF is all about. And here at the end of the day, even though we use the specific libraries, we are getting this in the form of a document structure. It is a list of documents. So if I go ahead and say what is type of PDF document of 0, you'll be able to see, okay, it is of a document type, right? Now, that is the most important thing. If you now see that we have understood about document structure, we know how to read PDF and TXT. Now, don't you think you can actually easily find out how to probably go ahead and read the Excel, DB, any kind of files? And this is the task that you really need to do. How you'll do it? Just go to LangChain, document loaders, right? And you will be able to find out everything over here. Just go ahead and try it out. Try it out. Try it out. Try to see if the document structure that you're getting is good or not. So here there are so many different things. You can just go ahead and try it out. If you want from AWS S3, you want from AWS S3 directory, go ahead and just install this particular library, give this. But before that, you have to do the authentication and all, right? Once you do this, and once you're able to do it, you can use any kind of document loaders as you add. But at the end of the day, What is the best thing about this? At the end of the day, you are able to convert everything into a document data structure, right? Now, if you see with respect to data ingestion, here you have actually completed. Now, the next step is that I will move towards chunking. Okay, I'll move and show you how the chunking can be specifically done. What are the different ways of chunking that you can actually do? And then finally we'll see that how we can even convert into embeddings. We'll try to use an open source embeddings for this, and then finally a vector db. So yes, I hope you have understood about the data ingestion part. Now let's move towards the chunking part, where we will understand how we can actually performing chunking, and I have also told you what is the importance of chunking. Quickly, let's go ahead and see the embedding part. So for the embedding, I will just go ahead and write a markdown. So let me quickly write embedding and vector store db, right? So we are going to specifically go ahead and implement these two important modules. Now, first of all, what I do is that I definitely require some kind of libraries over here, right, for embeddings. So for embedding, we are going to use sentence transformer. We are going to use a model that is available in Hugging Face. And for that, I will be using the sentence transformers library. Along with this, I also want to use some kind of vector store. So this is the vector store I may use, that is Fires CPU. You can use Fires, or you can also go ahead and use ChromaDB. So these are some very good open source vector store that is available. Now these all libraries will be more than sufficient to get started with. So quickly let me go ahead and install it. So I will write uv add -r requirement.txt. So once I do the installation, you'll be able to see that. Okay, the installation will get completed. So once the installation gets completed, it will take some amount of time because we are loading the entire transformers. So here you can see that quickly it has got installed. Now I'll go again back to over here. Now, once I go over here, what is the first step that I'm actually going to do is that I will quickly go ahead and import some of the libraries that I require, like this, right? So I'm importing NumPy from sentence transformer. I'm importing sentence transformer. My embedding model, right, will be available inside this. Then I'm importing ChromaDB. Then we are also importing the settings from this. We are importing UUID. The reason of creating this UUID is that because every record that we specifically insert into the vector DB will have some kind of ID over there, will generate that. Then along with this, we will also be importing list, dictionary, any, and tuple. And since we are going to apply cosine similarity while doing the retrieval from the vector DB, I also will be importing this, and this is available in scikit-learn. So let's quickly execute this. Okay, and till then I will go ahead and create more number of cells. Now, as I said, for embedding, I will go ahead and write one different class. So I will say embedding manager. So this will be responsible in doing the embedding part. So for first thing is that once I am creating this, for every class that we specifically create, we need to write an init function. Okay, so init. So this is my constructor. You'll be seeing that it handles document embedding generation using transformer. Here we are initializing the embedding manager, and the model name that we are giving is all mini lm l6 v2. So this is available in Hugging Face, this specific model, all mini L6 V2, and this is responsible in specifically converting a text into vectors, and you get somewhere around 384 dimensions. Okay, then we initialize the embedding manager. Then model name is nothing but Hugging Face model name for sentence embeddings. We are going to use this. Okay, so here we are initializing the model name. We are saying self.model is equal to none. Okay, because here later on we'll initialize this value. This function is very important, load underscore model. So that basically means my next function will be load underscore model, and this model work is very simple. This function work is very simple. It is going to load this model, that is all mini L6 V2. Okay, so I will create another function which is nothing but underscore load underscore model. Why we write underscore? This is just like a protected function. If you know about classes, we use something called as a protected function, and within this protected function, within this class only, it will be accessible. So here what we are doing, we are using the sentence transformer, and whatever model name we have, we are loading it. Okay, we are loading it. So self.model of sentence transformer model, self.model name, then this will be modeled loaded, and here you'll also be able to get the dimension. For that we use a function called as get sentence embedding dimension, and by default it will be somewhere around 384 dimensions. Okay, that basically means every text will be converted into 384 dimensions. So once we have this init function, we have the load model. Now one more function that we require is generate embeddings, right? So here you'll be able to see that I will be seeing this generate embeddings function. Okay. So generate embedding is nothing but it takes the text that is nothing but list of string and it returns a numpy array. Okay. So here it generates an embedding for list of text. Very simple. So here what we are doing, we are basically using this self.model. Encode is the function that we have to use on text, whatever text list of text we give. And we are also giving show progress bar is equal to true so that we should be able to see the progress bar and we return the embeddings. Okay. Now, generate embedding is one function, load model is one function. We have also used get sentence embedding dimension just to get the dimension. Okay. Now, for this, you can either you can either create this particular function or you can also remove this. It is not necessary. But what I did is that to show you much more in a better way, we will create this function get sentence embedding dimension. So here is my get embedding dimension self. So here what we are doing, we are just written model.get sentence embedding dimension. See, instead of doing like this also, I can write like this only over here. Okay, I can just quickly write this particular function over here. Okay, so sometimes it is not required. You can also, so I will just go ahead and remove it if you want. Okay, I will just remove it. Perfect. So I have these three important functions. Now we can initialize the embeddings. Okay, sorry, we can initialize the embedding manager. So here I will write embedding underscore manager is equal to embedding underscore manager. So I hope this is the class name. It should not be underscore, it should be like this. Okay. Now once I go ahead and write this and once I execute it, this will just go ahead and initialize the constructor, right? So here you can see it is loading the embedding model all mini LM v62 model loaded successfully. And here you can see the dimension is 384, right? So it has been loaded. So when we are calling this particular function, this is basically getting loaded, right? So my embedding manager now has the model information over here. Great. So I have my model ready. So if you see from this particular graph, this entire class has been created. Now we go to the next step and create this specific class. That basically means over here, we have our model embedding ready. We just need to use it. Now, similarly, we will go ahead and create it for the vector store also. Okay, vector store is just like a vector DB database where you can store all the vectors that is being converted by the embedding layer inside it so that you can apply any kind of similarity search into it, right? So first of all, let me quickly go ahead and define a class for this also. So here I will go ahead and write vector store. Okay, vector store. Remember guys, the code that I'm showing you is very simple. If you just see, you need to have some coding knowledge if you really want to become better in RAG. Okay. Now we'll go to the next step with respect to the vector store. Now in the vector store, we are creating a class vector store. Again, here we are using an init method. We are giving a collection name. What should be the collection name for the vector store itself? And here the collection name, we are giving it as PDF documents. We are also giving the persistent directory, which will be this particular directory that is inside my data folder. Persistent directory means whatever vector store is basically created, we are going to save it that in the hard disk. So here, first of all, I'm giving the collection name, I'm giving the persistent directory, collection is none, self.collection is equal to none. Okay, and then we are initializing the store. Now, whenever we initialize the store, that basically means this function will be initializing the vector store itself, right? So for this, we need to create another function again and see the code. Okay, just observe the code. Here we are initializing ChromaDB client and collection. So here we have written os.make directory of self.persistent directory, whatever directory path is there. If it already exists, we are just going to keep it like that. Otherwise, it is going to create a new directory. Then we create a client, self.client, wherein we are using ChromaDB.persistent client function, and we are given the persistent directory over here. So what it is going to do, it is basically going to create a client which will be having a reference to the ChromaDB vector store. Okay. Then we go ahead and create a collection. So here we write self.collection, then self.client.get or create collections. We're giving the collection name and we're giving some metadata information, like what is the collection information. And here we basically create a collection. Collection basically means it's just like where we are going to store the where we are going to store the vectors inside my vector store. So it will be stored inside this particular collection name. Then we are initializing this with the collection name dot collection count. Okay. So as soon as we execute this, that basically means my ChromaDB client will be ready and my collection will be created. Okay. Now the next function is that usually whenever we create a collection, we need to add the documents, right? So for documents, we will be creating another function. So quickly, let's go ahead and create this, because whenever I have a document, I will go ahead and create this particular connection. Okay. So here you can see I've created another function which is called as add document. Here we give the list of document, we apply the embeddings. Very simple, add documents and the embeddings to the vector store. And here you can see if length of documents is not equal to length of embeddings, here you can actually see this. Now we are preparing the data for ChromaDB. We require IDs, metadata, document text, and embedding list. So now whatever documents I have over here, whatever documents I'm getting, I will be zipping it, means I'm creating a tuple with embeddings, and then I am creating a UUID. Why I require UUID? Because it's just like a ID for a specific record, right? And that will be my doc ID. Okay, doc ID variable, and I'm appending it over there. Then we are preparing the metadata, whatever doc.metadata we get. Remember, we are iterating through these documents, so we have all the information. So that all metadata we are putting it over here, doc underscore index, content underscore length. We are just adding some more metadata information to put it inside my vector DB. Then we get the document content from doc.page underscore content, and we also get the embedding where we are converting this embedding to list. Okay, see, two information is basically required right over here. If you see from this particular function, one is embedding, which is my mp.nd array, right? And this embedding is coming from where? From the previous function, right? Generate embeddings, where we have done it. So it's all linkage. See, the reason of creating this particular in the form of class, because I want to link each and every pipeline, right? So here we are writing embedding list.append embedding.toList. So we have the page content, we have this list. So what I'm doing, I'm adding that entirely in the collection. So for this, we require IDs, we require embedding list, we require metadata, we require document text. So whatever we have prepared, we're just adding it over here based on the parameters, right? And finally, you'll be able to see the how many number of documents has been inserted. Now quickly, let's go ahead and initialize. Let's go ahead and initialize my vector store. So I'll write vector store is equal to vector store, and I'll initialize this. Okay. So quickly, I will go ahead and write vector store. So now this is basically going to initialize the entire vector store itself, right? So here you can see this is my collection name, and existing document in collection is 0, since we did not add any number of records. Okay. Now, if we want to add any number of records, we have to call this function add documents, right? So let's go ahead and do that, and let's call it. Okay. Now, first of all, you know that I've already done the splitting of the chunks, right? So here, if you go ahead and see this, this is my split underscore chunks, right? Sorry, that was the variable. Let's see which variable it has got saved. Okay, it should be chunks, right? So these are my chunks, right? Now chunks, what I am actually going to do is that I will extract all the text from that particular chunk and we'll generate an embedding. Okay. So for that, what I will do, I will say, I will put a list comprehension. So here now let's convert the text to embeddings. Okay. We're going to go ahead and do this. And here we are basically going to write chunks. First of all, I'll iterate. Okay. I will say that, hey, for doc in chunks. Okay. And we are just going to take this doc dot page underscore content. Okay. So we are going to take all this page content and basically go ahead and create my text variable. Okay. So once I go ahead and do this, you should be able to see this is my text, right? All the text that I have, and this text I will pass it to my embedding manager, right? Embedding manager, which I have actually created. So what I will do quickly, I will just go ahead and execute this once again. I have all my text. Okay. I have all my text. Now from this, we will go ahead and generate the embeddings. Now, once we generate the embedding, how do we generate the embeddings? Very simple. We use this embedding underscore manager, which object we have actually created. What object we have created earlier? If you see over here, this is my embedding manager, right? So we are using this embedding manager dot generate embedding, and here I have to give the text in the form of a list of strings, right? So here quickly I will call this particular function dot generate underscore embeddings. Okay, and here you will be able to see that I will be giving my text. Then let's store in the vector database. So after we convert that into an embedding, we store everything in the vector database, right? So here I will use vector store vector underscore store, the variable that we have created, dot add underscore documents, and this is a small letter, add underscore documents. This is a function that we have used, and inside this, if you remember, we have to give our entire chunks, okay, comma, whatever embeddings we are specifically applying. Okay, so once we do this, you can see this embeddings, whatever we have got, and the chunks, the documents, the entire documents, we are going to do this. Okay, so let's quickly execute this, and I think now my embedding will happen. Now you can see that for 359 text, this is happening, and it has got converted into so many number of batches. Vector store is not defined. Why it is not defined? Let's see what I have defined over there. Okay, it should be vector store. So this should be the spelling of my vector store instead of that. Okay, so now let me quickly go ahead and execute this. Now inside that same vector store, it'll get executed. Okay, perfect. Now you can see that the total document in the collection is 359. So if you see over here, inside my notebook file, inside my data file, here there is something called as vector store, and we have done the persistent over here, right? So persistent basically means it is saved in this particular hard disk. We can just load this hard disk and we can probably go ahead and execute anything as such. Okay, now perfect. Now you can see that we have completed this entire pipeline. Now we have all the data available over here in the vector store DB, right, in the form of vectors. But now the main thing is that how do we perform the retrieval? Because the retrieval, see, in retrieval, what happens is that whenever we have a user query, we have to take this query, we have to convert that into embeddings again. Okay, and then we basically go ahead and hit the vector store in the form of a retriever, and then only we get the context. So in our example, first of all, we'll try to get till here. Okay, we have a user query, we convert that query into embeddings, then we hit this particular vector store and we get the context. So let's go ahead and create this specific pipeline now. Okay, and for this pipeline, we will try to create a RAG retriever. Okay, so we will try to create a RAG retriever. So let's quickly go ahead and do that particular thing. Till now, we have created all the amazing pipelines. We have created this embedding manager. Now we also have this vector store. Now what I will do is that I'll create another pipeline, which will be a RAG retriever. Okay, just to get the specific context. So let's go ahead and discuss about that. So guys, now let's go ahead and create the RAG retriever pipeline. So first of all, what we are going to do is that I will go ahead and create a class, which is called as RAG retriever. Now this RAG retriever class, you will be able to see that it handles query-based retrieval from the vector store. So inside the constructor, we will be giving two important parameters. One is the vector store and one is the embedding manager. And if you remember, we have created both this. We have created the embedding manager, we have created the vector store manager, right? Now, after giving this, we will be initializing two class variables, that is vector store and embedding manager, and we'll be assigning with this. Now, whenever we create a retriever, one thing you really need to understand, this retriever is actually built on the top of a vector store. And retriever is nothing but it is a simple interface based on whatever query we get. This retriever is just going to give you the response back. Okay. And this retriever is basically a kind of interface which is connected to the vector store in short. Okay. Now, the next step that we are going to create is another function which will be called as retrieve function. Now, this is really important because this retrieve function main work is to retrieve based on a specific query. So let me go ahead and define the specific function. Now this function, again, see, to write it will definitely take a lot of time. So we will try to understand this particular function. Okay. So here a retrieve function, you can see we are giving query, we are giving top k results, how many top k results we want. And there is also a threshold value. By default, it is 0.0. And this function is basically going to return a list of results. Okay. So here you can see retrieve relevant document for a query. Arguments are the search query, top k documents and score threshold. And it returns a list of dictionaries contain the retriever documents and metadata. At the end of the day, this function is actually help us to get this specific context. So you will be able to see over here, we are using that same self embedding manager and we are calling this generate embedding function. Now, if you remember, this generate embedding function is already defined in my embedding manager, right? So if I go on the top, so here is my generate embedding function. And this is nothing but this is basically you're just using model.encode and you're giving the text and it is converting into embeddings. Yeah. So that is the reason we are basically using this. Because at the end of the day, first of all, whenever we get a query, right? So let me go down over here. Inside this retrieve, whenever we give this query, first the query needs to be converted into an embeddings, right? So this query that is given, we need to apply embedding for this also so that we can do a similarity search in the retriever itself, right? So the first, the query is basically converted into a vector by the help of embedding manager generate embedding functions. Then we are going to use the vector store dot collection and we are going to use this dot query. And here we are going to give our query embedding, which is nothing but this embedding in the form of a list. And then we are also going to give the top k results. So by using this, this is basically going to hit the vector DB, whichever vector DB we have initialized, and it is going to give you the results. Once you get the results internally, there will be a key which is called as documents. Okay. You can get document information, the metadata information, the distance information, and some of the IDs information. So all the specific information we are using it. And here you can see very similarly what we are doing. We are using all these parameters like ID, documents, metadata, and distance. We are zipping it. Zipping it basically means we are just trying to create a tuple over here. And then for every values, we are just trying to calculate the distance, right? 1 minus distance. 1 minus distance will basically give you the similarity score, like how similar those text data is basically coming up outside this vector store. So we are getting the similarity score. And if the similarity score is greater than the threshold, then what we do, we basically add this inside my context documents. And context documents is basically created in this particular variable, which is nothing but retrieve docs, which we have kept it empty over here. Okay. So all the information we are just trying to add it over here so that we will be able to see it. Okay. And finally, we return that retrieve docs. So if you say step by step, we're not doing anything. We like not very complex thing. We are getting the user query. We're converting this into embeddings. We are hitting the vector store, right? Then we are getting the response. Okay. Once we get the specific response, that context, we are putting it in the form of a list. If you just go ahead and see the code, that is how things are happening. Okay. So this is one of the very important function that you will be able to see. Now here, what I can do is that I can quickly go ahead and create a variable called as RAG retriever. And I can call this same class. So if you see over here, I will use this same RAG retriever over here. And let's give our vector store, vector underscore store, which I have defined it earlier, which is my vector store manager, and then my embedding manager. Once I do this, I should be able to see this. Okay, it should be vector store file, right? So now you will be able to see this is my RAG retriever. RAG retriever, it is an object of this. Now, if I call this particular function with a query, right? I can call dot retrieve with a query. So let's go ahead and do this. Okay, so here I will write RAG underscore retriever dot query. Sorry, dot retrieve is my function. Okay, so here you can see quickly, this is my function retrieve, right? And I need to give a query. Now let's test for a specific query. I'll say, hey, what is attention is all you need, because I know inside my data there is a PDF file which is called as attention, or I have also created some kind of proposal over here, embedding some files are there. So we'll try to execute this. So here you can see, as soon as I asked what is attention is all you need, now it is giving me the top K for all, it is printing all the information, and it is generated embedding for one text, right? And the text shape is 1 comma 384, because I've used the embedding that is called as all mini LMV6 that creates a 384 dimension. Now once we go ahead and apply this particular function, right, this function, it is basically getting the results over here, and we are printing that same thing, right? And at the end of the day, we can also go ahead and return this retrieve docs. Okay, so in short, this is basic. This function is going to give me all the retrieve docs. So this is the retrieve docs. You can see content, metadata, author. So these are my context information. So here you can see attention function can be described as a mapping a query as a set of this one, and this entire thing is basically the context. So from this particular diagram, here you can see easily we are able to get the context, right? And this is nothing but this is your context. Now let's try some more things. Okay, I will just go ahead and open some PDF. Okay, this is some very new research paper, COSO embedding technical report. Okay, we'll search for any topic over here. Embedding model training. I'll just go ahead and search for unified multitask learning framework. Okay, because this information also we have put it over there. So here I'll go ahead and create one more, this one, and I will copy this entire code. Okay, quickly. And this is the query that I'm actually going to give. That is nothing but unified multitask learning framework. So if I go ahead and execute this, you can see that I'm able to get this, and then you can see content, benchmark, ranking over on both the leaders, effectiveness of our approach. So we are able to get the response very, very much quickly, right? And this response is basically coming from the vector store, right? In a very similar way, very easy way, we are able to get the specific response over here, right? And let me tell you, right, this is the most easiest way, like how things are basically happening over here, right? Now, what we can do is that, see, if you have created all these things, right, till here you have created. Now, the further step is that you have to just integrate LLM with the with this specific context. Okay. Now, for this LLM with this specific context, what you can do is that you can directly take this particular context and give it to the LLM. And that is what we are going to see in the next video. But in this particular video, we saw the entire thing, the complete RAG pipeline from data ingestion to the vector DB pipeline, right? Now you can go ahead and write any kind of queries, and definitely with all this information, and here you can see similarity score is also coming up, right? Distance is also basically coming up. All the information you're putting it over here. And we have also used modular coding, right? Now in the next step, what I'll do, I will take this vector store, and we will go ahead with the next integration, that is LLM and output, which I will say it as a retrieval pipeline. But this entire data ingestion pipeline with this query retrieval we have actually created. Now the next two steps is this one. And after doing this, we will try to convert the same code, whatever code we have basically written over here, in the form of modular coding, right? We'll try to see that how we can put this inside our source folder. So here what I will do, I will quickly create a source folder, and inside this source folder, I will show you that how we can take this entire pipeline and how we can actually create it in such a way that we have a kind of pipeline over here, right? Pipeline basically means from data ingestion to vector embedding, how in a sequential way we can actually go ahead and call it. But I hope you got an idea with respect to this entire code, and I hope you are able to understand it. So yeah, this was it from my side. I will see you all in the next video. This was it. Please make sure to hit like, share with all your friends. I'll see you all in the next video. Thank you. Take care.